Most of us think we've got the whole hot day thing figured out. Find some shade, drink a ton of water, and you'll be fine. But what if I told you there's a kind of heat out there where none of that works? A heat that literally makes survival impossible. That's the terrifying question we're going to tackle in this explainer. When does extreme heat actually become unlivable?
All right, so first things first, we need to get one thing straight. Not all heat is created equal. There's a new, and honestly, a much deadlier kind of heat that's becoming more and more common. Just let that sink in for a second. It doesn't matter how much shade you're under, how much water you're drinking. I mean, this quote just completely flips everything we think we know about staying safe in the heat. It's describing a situation where our go-to survival tactics are, well, they're useless. The only way out is to actually cool down the air around you. And folks, that's the scary reality of what we call extreme humid heat. So to really get this, you have to understand that there are basically two flavors of heat. You've got your dry heat. Think of a desert, right? That's usually caused by these big high-pressure systems that just trap hot air. But then you have humid heat, and this is a whole different beast. See, as the planet gets warmer, the atmosphere can hold more moisture, more water vapor, and that turns an already high temperature into something way, way more oppressive and dangerous.
And this isn't just theory. This is a real-world life-or-death situation. Take what happened in Karachi, Pakistan back in 2015. They were hit with one of these extreme humid heat events. Now, the temperature shot up to 45 degrees Celsius, which is incredibly hot, for sure. But it was the crushing humidity that made it so deadly. In just 10 days, at least 1,200 people died. And the reason why is terrifyingly simple. Our body's #1 tool for cooling down is sweating. But when the air is already saturated with moisture, your sweat has nowhere to go. It can't evaporate. Your natural air conditioning system just breaks.
Okay, so this whole idea of sweat not working brings us to a really important scientific concept. It's the thing that tells us exactly when heat crosses the line from miserable to unlivable. It's called the wet bulb limit.
Now, wet bulb temperature is probably not something you're going to see on your phone's weather app, but it's an absolutely crucial measurement. Think of it as a single powerful number that combines both the heat and the humidity to tell you one thing and one thing only. Can your body still cool itself off by sweating? It's not about how hot it feels, it's about whether your personal cooling system is even functional.
So how do they even measure this? Well, the old school way to explain it is pretty simple, and it's called the wet sock thermometer method. You start with a regular thermometer. Step 2, you wrap a wet piece of cloth, like a sock, around the bulb. Now, as the water evaporates from that sock, it's going to cool the thermometer down. This is exactly what happens when sweat evaporates from your skin. That final lower temperature reading, that's your wet bulb temperature. And here's the key. If the temperature barely drops, it means the air is super humid, and your body's going to have a really, really hard time cooling off.
And this leads us to a really critical threshold. Scientists call it the limit of compensability, but you can just think of it as the body's breaking point. This is the moment your body officially loses the fight against heat. Your internal core temperature just starts to climb, and there's nothing you can do to stop it. You can be sweating buckets, but if that sweat can't evaporate, it's not doing you any good. And here's the number that just blows my mind. For some people, especially older adults or those with health issues, that breaking point can be hit at a wet bulb temperature of just 19 degrees Celsius. I know what you're thinking. 19 degrees. That sounds nice, maybe even a little cool, but that number is incredibly misleading, and here's why. This table right here is the key to understanding why that 19-degree number is so scary. A 19 degrees Celsius wet bulb temperature does not mean it's 19 degrees outside. Look at the top example. That same 19 degrees Celsius wet bulb could mean it's a blistering 46 degrees in dry desert-like conditions. Or, check out the bottom example. It could be only 32 degrees, but in a super humid tropical environment. To your body, even though the regular thermometer readings are totally different, the stress is exactly the same. Both are equally dangerous. And of course, that 19 degrees C number is really just a starting point. An individual's actual limit, your personal limit, can be different. It depends on a whole bunch of things. Your age is a big one. Older adults are much more vulnerable. So are people with existing health conditions, like heart problems. But even if you're perfectly young and healthy, if you're out there doing hard physical labor, you could hit your limit way, way soon. Okay, so we've talked about the risk to an individual person. Now let's zoom out. Let's look at the big picture and see where on the planet these dangerous zones are most likely to pop up.
And, well, the projections are pretty sobering. Let's look at a scenario with 2 degrees Celsius of global warming. That's a threshold a lot of climate agreements are trying desperately to stay under.
Even there, about 35% of the Earth's land area gets hit with these dangerous wet bulb conditions. But look what happens if we let warming get to 4 degrees. That number jumps to over 60%. That's a massive, massive increase.
And the most important thing to get here is that these aren't just empty patches of land we're talking about. No way. These danger zones cover some of the most crowded, densely populated places on Earth. Even at that 2-degree warming mark, we're talking about huge swaths of India, the populated eastern coast of China, and yeah, even a big chunk of the eastern United States.
So this all leads to a pretty logical conclusion, right? If the only way to survive is to cool down the air itself, then the answer has to be air conditioning. But, and this is a big but, that solution creates its own really dangerous paradox.
So we have to ask the question, is air conditioning really our only hope here? I mean, on the surface, it feels like this perfect technological fix. It gets hot, you turn on the AC, problem solved. But relying on it as our only solution is, well, it's a deeply flawed strategy. For starters, let's talk about the climate cost. Right now, AC is already responsible for about 3% of all global greenhouse gas emissions. That's a decent chunk. But the demand for AC is expected to triple by 2050, and that creates this nasty feedback loop, right? The hotter the world gets, the more we crank up the AC, which uses more energy, creates more emissions, and makes the world even hotter. It's a vicious cycle.
But the paradox gets even deeper. First off, there's a huge equity problem. AC is expensive to buy and expensive to run, which means the most vulnerable people often can't access it. Second, AC doesn't magically make heat disappear. It just takes the heat from inside your house and pumps it outside, which actually makes our cities hotter overall. And finally, our electrical grids. They were just never built to handle the kind of massive strain that happens when literally everyone runs their AC on full blast at the exact same time during a heat wave.
Now, just picture this for a second. This is the nightmare scenario. A huge storm, like a hurricane, rolls through and knocks out the power grid for days. And right on its heels comes one of these extreme humid heat waves. All of a sudden, that one line of defense we were all counting on, air conditioning, is just gone. And you've got millions of people left completely exposed and in immediate danger.
But look, it's not all doom and gloom. We absolutely have other options. The biggest, most powerful thing we can do is switch our power grids over to clean energy. That way, our cooling doesn't make the warming worse. But there are also smarter ways to design our cities. Things like installing cool roofs that reflect sunlight, planting way more trees for natural shade, and building public cooling centers where people can go to stay safe. We have a whole toolbox of solutions.
Look, there's no doubt about it. We are headed into uncharted territory with extreme heat. The science on that is crystal clear. But here's the most important takeaway from all of this. We still have time to decide just how bad it's going to get. We have the knowledge, we have the tools to make our future safer and more resilient. So the real question, the one that's left for all of us, is what choices are we going to make?